Dear students, welcome back to this video series on signals and systems. So today we are going to see another classification of systems, that is time variant and time invariant systems. So what do you mean by time invariant system? First of all, let us see the time invariant system. So if the input and output characteristics of a system do not change with time, the system is called a time invariant system. You can see the input and output characteristics of a system do not change with time. The system is called time invariant system. So in the case of a continuous time system, let us take the input as x of t, and which is delayed by t0 units, that is x of t minus t0. So our input here is x of t. Okay, when we are applying the delay, so time delay or time shifting, you can see it is becoming t minus t0. So the signal is delayed by t0. Then the output of the system for the input x of t is given by, so let us see the output of the system. So output is y of t. So y of t is in fact, normally we are representing it as a transformation of x of t. Okay, y of t is a transformation of x of t. So we can see the output for the input x of t minus t0. So x of t minus t0 is the delayed input. So the output of x of t, so നമ്മൾ input x of t ആയിട്ട് കൊടുക്കുമ്പോൾ നമുക്ക് കിട്ടുന്ന output എന്നുള്ളത്, what is it? That is y of t ആണ്. Similarly, we are giving here input as x of t minus t0. So delayed ആയിട്ടുള്ള സിഗ്നലിനെ നമ്മൾ input ആയിട്ട് കൊടുക്കുമ്പോൾ, we can see its output is represented by y of t comma t0. y of t comma t0. So that means that is equal to y of t for every x of t, which is equal to x of t minus t0. Or simply we can see the input is x of t minus t0, so that the output is represented as y of t comma t0. Okay, so the output for the delayed input. Similarly, we can also consider the output that is delayed by t0, and that is represented as y of t minus t0. So output delayed by t0 is given by y of t minus t0. y of t minus t0 എന്താന്ന് പറഞ്ഞാൽ y of t for every t changed to t minus t0. y of t for every t changed to t minus t0. So if these two outputs, that means y of t comma t0 and y of t minus t0 are the same, then we can say that the system is time invariant. Okay, that is when the delayed output of the system is equal to the output due to delayed input for all possible values of t, then the given system is a time invariant system. Okay, so we can see y of t minus t0 is equal to y of t comma t0. So if a continuous time system is described by a differential equation, and if the coefficients of the differential equation are constants, then the system is called a time invariant system. So systems in a, especially continuous time systems in the case എടുക്കുമ്പോൾ നമുക്ക് systems are represented by differential equations. So if we have a differential equation of this form, whose coefficients, coefficients of the differential equation, so we can see here the coefficient is 5, 4 and 3. Okay, and you can see 2 here. So if the coefficients of differential equations are constants, then we can say the system is time invariant. So നമുക്കൊരു differential equation തന്നിട്ടുണ്ടെങ്കിൽ അത് time invariant ആണോ എന്ന് കണ്ടുപിടിക്കാനായിട്ട് simply we have to look at the coefficients of the differential equation. If they are constants, then we can say the system is time invariant. Similarly, we can see in the case of discrete time signal. So discrete time signal എന്ന് പറയുമ്പോൾ നമുക്കറിയാം discrete time system in input, that is x of n, So that is given to a discrete time system. So I put it as, say, dt system, discrete time system. So what we are getting is y of n, that is the output of the discrete time system. So now consider the input delayed by k seconds or k units. So that is input delayed by k units means x of n will become x of n minus k. So if we give the input, the delayed input to the system, so this delayed input x of n minus k എന്നുള്ളത് ഇൻപുട്ടിലേക്ക് കൊടുത്തു കഴിഞ്ഞാൽ നമുക്ക് കിട്ടുന്ന ഔട്ട്പുട്ടിനെ നമ്മൾ റെപ്രസെന്റ് ചെയ്യുന്നത്. So if the input of the system is x of n minus k means ആ delayed signal നമ്മൾ input ആയിട്ട് കൊടുക്കുന്നു എന്ന് വിചാരിക്കുക. So then the output is given by, here in this case we can represent output as y of n comma k. Okay, y of n comma k. Similarly, the output of the system delayed by k units. Now we can consider the output of the system y of n delayed by k units, that is y of n minus k. So y of n minus k എന്താണെന്ന് ചോദിച്ചാൽ that is y of n for all n changed as n minus k. Okay, this is y of n minus k. So if these two outputs, that is y of n comma k and y of n minus k, are same, then we can say that the discrete time signal is time invariant. Otherwise, if this condition is not satisfied, then we have to consider the system as a time variant system. Okay, time variant system. Now, if in the case of a discrete time system, so we know that the discrete time system is represented by difference equations. Difference equation. So if the coefficients of the difference equations are constants, then we can say the system is a time invariant system. So നമുക്ക് ഒരു discrete time system തന്നിട്ടുണ്ട്. That discrete time system is represented by a difference equation of this form. And if the coefficients of this difference equation are constants, then we can conclude that the system is a time invariant system. So we can see here the coefficients. Y of n in the coefficient 1 ആണ്. Here y of n minus 2 in the coefficient 5 ആണ്. Y of n minus 1 in the coefficient 4 ആണ്. X of n in the coefficient 5 ആണ്. Okay. So all the coefficients here are constants. Okay. So if all the coefficients are constants, then we can say that the system is time invariant. Okay. Otherwise, if it is a function of n, so e 5 ന് പകരം if it is given as 5n, okay, so then we have to consider that the system is the coefficient is not constant, but it is a function of n. Then we have to conclude that the system is time variant. Okay, so this is what is meant by time invariance and time variant system. Okay, time invariant and time variant systems. So let us see the tutorial problems in the next video.